So now we have the review for next set. First problem is a wonderful brain teaser. It's about 2 fuse. Each of them can burn for 1 minute. And then we want to use these 2 fuse to measure out exactly 45 seconds. And the key is, like we draw over here, the fuse are not even. They are not even within themselves, within itself. So some part it might burn slowly, some part over here that might burn quickly. So you cannot measure the length by saying that's proportional. Okay? So that's the key. That's number 1.
And in number 2, we have a quadrilateral whose coordinates we know, A, B, C, D. And we are drawing a line through a point A, dividing its area in half. We would like to find the coordinates of this point where this line intersects the quadrilateral. These are 2 rational coordinates we would like to find them.
And number 3, so this problem is a problem I wrote for Arnold back in 2008 or 9. It's about arranging numbers 1 through 8 into this 3 by 3 box, leaving one of the box open. And a legit arrangement is between every 2 neighboring numbers, their difference is at most 2. Okay? So this is not a legit arrangement because 1 and 4 are neighboring each other.
Yes.
Okay?
And one of the squares you can block.
Right? So this is a much easier version of a very hard problem. Is if you do put in 1, 2, 3, 4, 5, 6, 7, 8, 9 into it, then there always a pair of numbers that are what?
There will be distant
Different 3. And this is, in general, this is always true. If you put 1, 2, 3 all the way to n squared into n by n squared, then there must be pairs of what? Neighbors. Their difference is at least n. And actually we can even find what's the minimum number of those pairs are there. Okay? That's an IMO problem, one of the very hard ones. Appeared in 1989 shortlist. We will talk about them later. So this is a simple version. So without that number, it's doable. And for this particular 3 by 3 grid, we want to know how many such arrangements are there. Okay?
So for number 4, we have 10 sheets of paper, and on each sheet we write various powers of 2, such that the sum of the numbers on each sheet is the same, and we are allowed to use the same power of 2 multiple times. So the question is, given that the maximum number of times that any one number appears on those sheets is m,
Yeah, big M.
big M, we're trying to minimize this value.
So
So
of course, n is less than 10. You can write every number out there.
Yeah. Also remember that you can write the same part of the even on the same sheet.
Yes.
So we're trying to minimize that.
So in number 5, we're doing the second part of the diagonal problem, where in the first part we show that all odd n works, and in the second part we want to show that it's like we want to find all n that works. So we find all odd n's and what about all the even ones. So just to recap, the balance means that for any 2 points A and B, there exists a point C such that which is equidistant to both points. And set free means that there does not exist a point that's equidistant to the 3 other points.
So besides this very folklore brain teaser, all of these problems are coming from different contexts. And we like them a lot. This one is come from the AMC 10 or 12 contest in the recent years. And this one is in Arnold. And this year is from a recent Russian Olympiad. And this one is from this past IMO.
All right, so we'll see you next week.